So now let's go down to molar mass. It is very simple. When we say molar mass, it simply means mass of 1 mole. Mass of 1 mole. What do we mean by that? If you check up here, you can see that 1 mole of everything contains the same number of atoms. But it doesn't make sense when we just try to say, for example, we say a dozen. Of course, we know that a dozen is the same number. So a mole is the same number as well. So a mole of anything will contain 6.02 times 10 to the power of 23 of that thing. So, but if you say a dozen of egg, and we compare it to a dozen of elephants, a dozen of eggs are just 12 eggs, and a dozen of elephants are also 12 elephants. But what about the mass of each one of them? Can we say because they are 12, 12, they have the same masses, or they have the same mass? No. Mass, definitely elephant will be heavier than 12 elephants. Definitely have to be heavier than 12 eggs. So that is why we need to look down into the mass of 1 mole of any substance. So when we say molar mass means mass of 1 mole of a substance. If you take 1 mole of any substance and you weigh it, the mass you get is the molar mass of that substance. So we have some of them here. We have some examples here. We have um, nitrogen. So nitrogen atom. So that's why we said atomic nitrogen here. Nitrogen atom will have, if you weigh nitrogen atom. So when you see N like this N means 1 mole of nitrogen atom. So for example, when you write A, it means 1A. If it's going to be 2A, we'll put 2 in front of it, 2A like this. So all this one, they're just like 1 mole, 1 mole, 1 mole, and 1 mole. So 1 mole of nitrogen atom has this number of particles, number of atoms in it. Of course, you remember. But if you try to weigh that 1 mole of nitrogen atom, it will weigh 14.0 grams. This is the molar mass of nitrogen atom. That is the mass of 1 mole of nitrogen atom. So the same thing, if you go down to nitrogen molecule now, remember, nitrogen molecule contains 2 atoms of nitrogen. Although this is still 1 mole because it is 1N2. We have N2 like this. If I ask you how many N2 can you see on the board, you will say you can see only one N2. So it means that is 1 mole of nitrogen molecule. And of course, since it is 1 mole, it will contain 6.02 times 10 to the power of 23 molecules. So if you have N2, you have a cup of N2 like this, and that cup is 1 mole. If you try to count all the N2 in that one cup, it will be 6.02 times 10 to the power of 23 molecules of N2. But if you weigh this now, if you weigh all this N2, it will be 28 grams. So of course, because this is a multiple, this double of nitrogen atom. So if nitrogen atom weigh 14 grams, N2, which is nitrogen molecule, will weigh 28 grams. But number of each one of them is going to be the same inside 1 mole. For silver, it is similar. You can see 1 mole of silver, it contains these silver atoms. But if you try to weigh it, it is going to be 107.9 silver atoms. The same thing for silver ion. It's going to be this symbol of silver ion. 1 mole of silver ion will weigh this. The molar mass will be 107.9 because when we say silver ion Ag plus, it means it lost only 1 electron, and mass of electron is highly insignificant. Again, apart from that, we use the mass of proton and neutron to determine the mass of an element. So when you have Ag plus, which is silver ion, and Ag, with the silver atom, they will have the same mass. This one it lost one electron actually, but mass of electron is highly insignificant. So that is why this one it has the same mass as silver. Silver ion and silver atom, they have the same mass. And then they have the same number of particles as well. This one of atoms, this one of ions. For barium chloride, this is a molecule, this is a compound now. Barium chloride, if you write BaCl2 like this means, if I ask you how many barium chloride do you see on the board, you will say you have one. If there are two of them, it will be two here. So that one means 1 mole of barium chloride. So 1 mole of barium chloride, of course, if you count the particles of barium chloride in that 1 mole, it will be what? It is going to be 6.02 times 10 to the power of 23. But if somebody asks you, how many barium ion are there in 1 mole of barium chloride? So of course, 1 mole of barium chloride contains 1 barium ion. So, understand me right? And then we know that 1 mole of barium chloride has 6.02 times 10 to the power of 23 barium chloride units. If you keep counting them, 1, 2, 3, 4, this amount you will see. But 1 barium chloride like this has 1 barium, right? There's 1 barium in 1 barium chloride, and there are 2 chlorine atom in 1 barium chloride as well. So if you take 1 mole of barium chloride, 1 mole of barium chloride, BaCl2, it has 1 mole of barium. And the same thing, 1 mole of barium chloride has 2 moles of chloride ion, Ba8 plus and Ba2 plus and 2Cl minus. So this is ratio 1 to 2, and that is why this is being multiplied by 2 here. So when you have this, is if you convert this one to this mole to number of atoms, this is going to be 6.02 times 10 to the power of 23 particles of barium chloride. But if you want to count that in terms of chloride, since the ratio of the particles of barium chloride to ratio of the chlorides inside that particle is 1 to 2. So how many chloride atoms do you have? Chloride ion do you have there? So it's going to be 2 times this number. So that is why it is multiplied by 2 here. That is how we relate the number of mole, the molar mass, and the Avogadro's number. So we're going to see the calculation as we go. I will go further into the calculation now. So this is, before the calculation, is just another explanation or another illustration for us to see. I can zoom it more a little bit so you can see it better. So we have 3 states of matter here. There's a gas, which is represented by oxygen. We have liquid, which is water, and then we have solid, which is sodium chloride. So assuming that they are all 1 mole. So if you try to weigh, of course they are all 1 mole, but we cannot say they have the same mass. No, this is a gas, oxygen gas. So 1 mole of oxygen gas, if you calculate it, it is 32 grams. That is, we have, this is O2, so O is 16, so we have 2 of them. It's going to be 16 plus 16, which is 32 grams. That is water. 1 mole of water is 18 grams. That is, mass of 1 mole of water is 18 grams, which is molar mass of water. Molar mass of oxygen molecule is 32 grams, and molar mass of sodium chloride is 58.45 grams. Of course, you know how to do the calculation. But each of these sample, they will contain the same Avogadro's number, the same formula units. of course, because we are dealing with one mole, because number of moles is going to be is the same. So definitely number of atoms in each one, or number of particles in each one of them, will be the same. So however, the masses will be different. They will weigh differently because they don't have the same weight.